Okay, so we have a couple of things. We've been studying the first derivative and what happens with slopes of tangent lines. The second derivative is going to give us some information about concavity. So functions. I like to self-mutilate. That's why I see Band-Aids all over my hands here. Concave up. Actually, my dog bit me. Yep. No, I was too busy getting him out of a foothold coyote trap. Yeah, it was very nice. My thumb hurts, though. Because he was panicky and it hurt when I grabbed the trap and twisted on it. Okay, concave up and concave down. Pretty basic concept. What's happening to the derivative here? The derivative is negative, yeah. So increasing. And here it is positive, 0 to negative, decreasing, right? So there's one way to tell concavity. Find a critical point and analyze the derivative. All right. Okay, so first method, we've already been through it, right? Min and max, that was what 4.3 was partly about. The other way to do it is the second derivative. If the second derivative is bigger than 0, f is concave up. And if the second derivative is less than 0, f is concave down. All right. I'll show you an example here in a bit, but I want to talk points of inflection as well. Are you good with that? Pretty straightforward. Okay, what if I have a function that does this? I know these are critical points, right? But what about that transition point from concave down, concave up? Okay, some of you know, it's called a point of inflection. It's where you change from, it's change in concavity. Okay. Okay, here's how we know if we have an inflection point. Okay, the second derivative is 0. So first derivative was 0, gave us critical points. Second derivative 0 gives us points of inflection. If and I'm having trouble here writing with my bum thumb. Okay, so the second derivative is 0, and the second derivative changes sign at x. So that's what's required for an inflection point. Okay. Let's do some math examples. Okay, let's find the points of inflection and the concavity of cosine x on 0 to 2 pi. What's the derivative? And the second derivative? Okay. So for points of inflection, we have to figure out where this equals 0, right? So where does negative cosine x equal 0? It starts at -1, goes up to 1. This is where knowing those parent graphs really helps. Okay, we're looking for this point, which is at pi over 2, and this point, 3 pi over 2. That's how I remember it. Draw the graph. Okay. Yeah, so those are possible points of inflection. We have to have a sign change in on the second derivative too. So it's easiest if you make a table. Okay, so the first thing we're going to look at is the intervals from 0 to pi over 2, pi over 2 to 3 pi over 2, and 3 pi over 2 to 2 pi. Those are our intervals that we can consider because our points of inflection determine the cutoff points there. Okay, we need some test values. Okay, let's do power 4 then. What's f double prime? Now we're analyzing these in the second derivative. So what's f double prime at pi over 4? Yep. The sign of that is negative, which means what about concavity? Down. Okay. Okay, the next one, what's f double prime at pi? 1, which is positive concave up. Yeah. Okay, you getting the hang of it? It's easiest if you stay organized. So what are my points of inflection officially? Here? That's 7 pi over 4. It's between 3 pi over 2 and 2 pi. Because this is 6 pi over 4 and 8 pi over 4. I am calm. Okay, I'll take my foot off the gas pedal. But I'm still going to coast. All right, you okay with that? Do you want me to show you an example where the second derivative doesn't exist? Like example 4 in your book. Or you can just look at it. Tell me what you want. No, you still have to finish it. Okay, so let's say I have this here. Okay. The derivative and then the second derivative notice that the second derivative is a negative exponent. Okay. Can that happen? Okay, so f okay, it doesn't exist at x equals 0, the second derivative. But I still need to test in my intervals because I can still have a concavity change and it can still be a point of inflection. So, are you getting infinity and 0? Well, 0 is your point of possible concavity change. Okay. Because f double prime at 0 does not exist. So that's what we're going to test for concavity change.
So -1, f double prime at -1 is negative, concave down. F double prime at 1 is positive, concave up. Right. This is f double prime at -1 and f double prime at 1. Oh, it's negative and positive. That's all you need to worry about. So. Okay, so those ones can get a little bit funky, but since the second derivative changes sign at x equals 0, that point is a point of inflection. So you're looking for a sign change in the second derivative. Got it? Good. Okay, so there's the homework. Due Thursday. That'd be better for me. Going out to figured that today's probably the only day I could do it.